Hi, and it's a great day to do some AP Chemistry exam review. It's me, Dr. V, and in this webcast, we're going to talk about free response question number 4 from the 2025 exam. This was a short free response question, and that means it was scored out of 4 points. These short free response questions usually involve 3 to 4 parts. You do want to make sure when you're doing the free response questions that you are keeping track of your time. It should be about 8 to 9 minutes. Before we get started, grab your calculator and your periodic table and your formula sheet. I don't want this to be just you listening to me telling you how to do the problem. I want you to try to do it on your own. That's what's really going to benefit you. So listen to me introduce each part of the problem and then pause the webcast, try to answer it on your own, and then listen to my explanation and score your work. Did you earn the point? Did you not earn the point? What do you need to do to enhance your answer to get full credit? That's really the best way to use this webcast. All right, let's jump right in. A scientist is investigating the properties of a mixture of CH3OH, which is methanol, and H2CO, which is formaldehyde. The scientist generates the following diagram to represent the mixture. Part A of the question asks, identify the hybridization of the valence orbitals of the carbon atom in the H2CO molecule. Well, there are several H2CO molecules in the drawing. Here's one. All you had to write down here was sp2. They asked for hybridization, so your answer is going to be sp, sp2, or sp3. Here it's sp2. That's what you had to write for 1 point. Why is it sp2? There are 3 electron domains around the central atom. I have 3 atoms bonded to the carbon. There aren't any lone pairs on the carbon. So 3 electron domains, that's sp2 hybridization. I do want to point out that the question did not ask you to explain how you arrived at your answer. So don't give that. Don't write that down. I'm doing it because I'm trying to be thorough to help you. And the test is going to be a little more limited. Going on, in the diagram provided, draw a single dashed line to represent a strong hydrogen bonding attraction between one methanol molecule and one formaldehyde molecule in the mixture. It's really important that you know the correct definition of hydrogen bonding. A hydrogen bond involves a hydrogen atom in one molecule that is bonded to an N, O, or F in that molecule. And that hydrogen atom is attracted to another molecule's N, O, or F atom. So let's start by identifying the hydrogen atoms in the molecules in the drawing that could participate in hydrogen bonding. We need a hydrogen atom bonded to N, O, or F. So the hydrogen atoms that I highlighted here in blue meet that requirement. They're both attached to oxygen. So we've got this really polar hydrogen-oxygen bond. And that hydrogen has a partial positive charge. It's looking for more electron density. It needs to be attracted to another molecule's N, O, or F atom. Now, we don't have any N's or any F's, but we do have O's in the formaldehyde molecules, and I've highlighted them all in purple. I need one of the H's that's highlighted in blue to be attracted to one of the oxygens in purple. I do want to point out that a common error is that students will often think any hydrogen can do hydrogen bond or that it's a covalent bond involving hydrogen. No. Be really careful. So there's really only one location where I can easily draw a hydrogen bond, and that's over here on the right. So I need to have that H highlighted in blue attracted to the nearest purple oxygen, and I'm going to draw my series of dots, or you could do dashes, to represent that hydrogen bond. Proximity does matter. Those are the only 2 that are really close enough to each other to form a strong interaction. All the other ones are just really strange angles or they're too far away. That's your best choice. That's what you had to draw for 1 point. As a side note, I do want to point out they only asked you to draw 1 dashed line. Only draw 1 dashed line here because if you draw more than 1 and it's a mistake, you don't get credit. The other common thing that happened with this particular question is that the hydrogen bond had to be between a methanol molecule and a formaldehyde molecule, between 2 different molecules. Don't add water, don't have it to the other methanol molecule. You needed to have the 2 different kinds of molecules interacting. So be careful about those details. They matter. The scientist plans to cool a gaseous mixture of these 2 compounds to form a liquid mixture and finds data on the 2 compounds, and the data are summarized in the table. So we have the 2 substances with their melting points, we have their boiling points, and we have the enthalpy of vaporization. Propose a temperature to which the mixture should be cooled such that both substances are liquids. So we have melting point data. We know that below the melting point, the substance will be a solid. Above the melting point, but below the boiling point, it would be a liquid. We have the boiling point data as well. Below the boiling point, a substance would be a liquid, but it has to be above its melting point. So what we really need is a temperature that's below the boiling point of both substances and that is also above the melting point of both substances. So something in between these. For example, you could write down 195 Kelvin. There were a range of answers that were acceptable for this problem. Any answer where the temperature was greater than or equal to 181 Kelvin and where the temperature was less than or equal to 254 Kelvin was accepted for credit. If you did a one-sided range, if you just said above a certain value or below a certain value, you did not get credit. You had to have either a specific number or a range that was in that region. That's what you needed to write for 1 point. I do want to point out again that the question did not ask you to explain how you arrived at your answer. You just needed to write down an answer. So don't write explanations if the question doesn't ask you to. There's a second part to part C. The scientists analyze the mixture after it is cooled and determines that 8.59 grams of liquid methanol is present. Calculate the amount of thermal energy in kilojoules that was removed to condense the 8.59 grams of methanol and were given its molar mass at its boiling point. So this is a mass-energy relationship where we know kilojoules per mole. You do want to make sure you use the right information. You need to make sure you're using the methanol, the CH3OH. You need to make sure that you're using the enthalpy of vaporization for methanol and not the information for the other molecule, formaldehyde. If you look at the units, however, for the enthalpy of vaporization, notice that they are kilojoules per mole of methanol. We have a mass of methanol, and so we're going to need to convert the mass of methanol to moles and then use the mole to energy relationship from the enthalpy of vaporization. It's really a factor label problem. So we have 8.59 grams of methanol. Conveniently, we're given its molar mass, and we can do this calculation readily. To calculate the magnitude of energy removed, I'm going to convert my grams to moles using the molar mass that I was given. It's so nice. And then I'm going to use the mole to energy relationship, and a magnitude of 10.1 kilojoules were removed. You might have written this down as a negative 10.1 kilojoules. It is being removed. That's fine. That's what you needed to do to earn the point for C Part 2. So how did you do? The average score on this question in 2025 was 2.32 out of 4. Out of the 4 short response questions, it was the highest scoring of those questions. So if you got 2 points, you're doing well. If you were 3 points, you're doing well. 4 points, yeah, very achievable. That's where you want to be. If you found this helpful, like the video and leave a comment, and remember to subscribe to my channel so you get all my latest updates. Keep studying chemistry every day. That's the key to success.